going to discuss class inheritance. So what do we mean by inheritance? Just like it's just the English word, you know, when you inherit wealth from your father or your family member. So that is what inheritance is also in class in JavaScript. So when you have class A, for example, and it has a lot of properties and methods, and you want to create another class B, you want to create another class B that need the things that are in class A. So you don't need to redefine those properties again in class B. All you have to do is inherit the properties from class A. So if we do class A, and our class A have, let's say, a property. Remember, the constructor is the first method that is called when you instantiate your class. So we want to set, say, name equals to A class, okay? And this class has a function, let's say test, all right? And this function is simply doing the console.log testing from A, all right? So if you instantiate this class, const A equals to new A, and you run a.test, you should get your console, right? Testing from A. This is exactly what we learned previously. All right, so now here is where inheritance comes in. Let's say we have another class, B, that need the method testing. So instead of us declaring this testing here again, all we have to do is write the keyword extends, then put in A, which is the class that you want to extend. All right, this is how you inherit from another class. So with the keyword extends and you put in the name of the class, it will automatically inherit all these things that is done here, okay? So whereby you come here and you say test2, which is another method in B. If you say console.log testing from B, okay? Now, if we come here and we say const B equals to new B, and B.test2, you see testing from B, testing from A, okay? So let's comment this one out, for example. Now, from our B, we can call test, which exists in A, all right? So if we run this, you see testing from A. Even though this method test was not defined in B, because we are extending A, that method is available for class B, all right? And we can also call its own method, which we define, which is test2, and you will see both are available, all right? When you do b.name, console log our name. So if you run this, you see here A class, because the what is it called? Our extend already instantiates this. So if we override our constructor in this place, and we put in our name, B class. Now, when you run this now, you will get, we need to call super, because this extend, they're going to be like a collision. So super, anyway, let me, I need to explain this carefully because it might be very confusing now. See this constructor. When you don't have constructor here, this constructor is executed during when you instantiate this one. And that is why you get a class, which is coming from this place, all right? So now we want to add a constructor on this class. So without this super, super means execute this constructor, which is the one we are extending. That is this super. Super will run this instance. If we don't have it, you see that JavaScript gave us error here. It said must call super constructor in the derived class before accessing this. All right, because we are doing this here, and we are extending a class A, is telling us that we must first of all call the super class to instantiate this one properly. Okay, so that is why we need to call this super first. If you don't call this super, you cannot use these dots inside here. All right. So when you run this, you see that our name becomes B. If I remove this, our name will remain A. Okay. So this is just overriding this one. Rather than it being A class, we want to give it its own name so that you know that we are in B class, okay? So if you run this now, you get B. Let's take another quick example. So let's say we have class car, and this car has name, and it can let's say when we instantiate this car, we want to give it a name. So name, and we want to give it a model. All right, model. Pay attention here so you understand what is going on. You see that this constructor has parameter. The one we did before doesn't have parameter. So pay attention to see new stuff here. So every car can drive. So we have a drive method. We're just going to do console log driving, okay? And every car can also stop when you step on the brake. Okay, so we're just going to keep it very simple. So this is general thing that every car can have, okay? So let's assume that we want to create car A, for example. So we know that it's a car, so we are going to extend the base class car, okay? Now we are going to create the constructor. This constructor does not have parameter. Remember that because we are extending a car, we have to call the super. Now, remember that our car constructor has parameter. This is where you pass the parameter inside the super, okay? So this is a car A as the name, and the model is maybe A class. Let's just call it that, A class, okay? So this is where you pass those parameters Because when you call this super, what it's doing literally is instantiating this car and is calling this constructor with all the parameters that you pass to it here, okay? So you should take note of that. And once you've done this, you can test your A already, instantiate the car A. And if you do a.name, don't forget the console. If you do a.name, you see A here. And if you call the model, you see A and A class, which is the model, all right? So remember that our car can drive, our car can stop. Because we are extending car, we can already do this, a.drive, all right? And you get driving. So now, any functionalities that you want to add to car A that shouldn't exist in the base class, you have to put here. Let's say this car has the ability to play music. All right, not every car can play music if you don't have the accessory to play music, okay? Music playing, for example. So let's assume that this is all the features our car A has. Now we want to make car B, extending the same car. We want to change this to B, and this is B class. Now our B class doesn't have ability to play music. Maybe it has back camera, okay? So maybe turn on reverse cam. Reverse camera on is on now. So maybe this is the utility for this car B. It's probably maybe it can also play music. So if it can also play music, you know, you can also instantiate car A. All right. So we will do that in a bit. So if we run this, you see that our driving is there. So let's say A dot, this is our car A. So we can say play music. And our car A can play music. See, music is playing. So the same, we can instantiate our class B. And B.name, B.model, B can also drive, and B cannot play music. It only have turning on the back camera, okay? So if you run this, you see A, driving, playing music, B class, driving, and reversing camera is on, okay? So this is the closest to real world usage of this extending classes. All right. Now you can also extend a class that extend other classes. Okay. So let's assume that we want to make another car, maybe car C. And this car C have exactly the same features as car A. So it can play music. What we have to do is extend our car A. Rather than extending car, we extend car A, all right? So now we call super. Now, when you call super, you need to pay attention here. When you call super, you are calling super of this one, which doesn't have parameter, okay? So this is hard coding this to B class. So if you call super and you call it like this, it will not do anything because this super does not have parameters. So you just call super, then you can modify the name like this. C as the name, and the model is C class, okay? And now we have our extending of car A, which is playing of music. Then maybe this one also have something else like what other feature can we have there? Maybe automatic door opening. So let's say closed door. Okay. Door closed. So if we come down here and we instantiate our C class, so if we call C, you will see that C can, what we extend is class A, which is play music. Remember, it doesn't have turn on count. So if you put play music and we run this, you see there, C class driving and music is playing. And you notice that our car C does not have any play music defined here. It's only defined in class A. And we can call that function. This drive is coming from the car class, which is the base class. This play music is coming from the class A, which is being extended. And we can also call its own defined class, which is closed door here. So let's comment this so you see less noise. And you see here, this is from the base class. This is the parent class. And this is the current class. Let's quickly talk arrow function. Arrow function is very, very simple, okay? Remember that the syntax of creating function is like this. Function keyword, the name followed by parentheses and the code block. And you put in what you want to run in here. Testing function, okay? This is your normal function. And you can invoke it like this, test, right? Let's comment this one. And when we run this, you get testing function. Voila, everything works fine, no problem. Now, for you to, arrow function is just like a short form of writing your function without the function keyword. Okay, so let's convert this same function into an arrow function so we see the difference. So when you are making an arrow function, you start with a const, followed by the name of the function, which is test. Then you make equals to, then you put in your parentheses, followed by this arrow, equals to and greater than sign, like this. If you follow it like this, the next thing will be your code block. So this is equivalent to this. And you can put your console log there. If we comment this one and run this code, we get the same results. So you put in the identifier, just like the way you create your variable, okay? It's just creating variable and assigning the arrow function to it. This is the arrow function. Only this one like this is the arrow function, okay? This one is just you collecting it in a variable, all right? Because you cannot keep this by itself. If we do this, it will, let's see. You see, there's no error in your console, but there's no way you can call this because you have not given it any name. Do you understand? You've not given it any name. that you can use to trigger it or reference it. So that's why you need to assign it to a variable, okay? Ideally, you should always use constant because you don't want your function to be changing, right? So that's why I used constant there. Do you have any question for this arrow function?
No.
Okay, so when you use arrow function inside a class, you know that this is a function, right?
Yes.
But I didn't put the function keyword there, right? So we can also define our function like an arrow function within our class. For example, let's take this class C. If I want to turn this to arrow function, I have to do this, something like this. This is an arrow function.